So today we're going to continue our lessons on 10.3 and ellipses, and we're going to learn a little bit more how to sketch the graphs and then also how to come up with the equations of ellipses when we're given certain pieces of information about the ellipse. So the first thing, let's figure out how to sketch an ellipse. We have the following equation: x minus 4 squared over 12 plus y plus 3 squared over 16 equals 1. We know this is an ellipse because our denominators right here are different. So we know it's an ellipse and not a circle. So now we need to find the critical pieces of information. We need to find the center, the foci, the vertices, the length of the major axis, and the length of the minor axis. And when we find all of that, then we can sketch an ellipse. So the center is pretty easy. The center of this ellipse is going to be h comma k. So the opposite value of -4, so I'll be +4, and then the opposite of 3 is -3. So there's our center. Okay, so now that we have the center, we're going to figure out what our major axis and our minor axis is. So this is a vertical ellipse because our larger number is underneath the y. So our major axis is going to be a vertical line. And that means that we know that a squared equals 16. So that means that a equals 4. So if you remember from the previous day, the major axis is going to be 2 times a. So that equals 2 times 4, which is 8. So now we know that our vertical line going through the point 4, -3 is going to have a length of 8 units. So now let's find the minor axis. So b squared equals 12. So that means b equals the square root of 12. And therefore the minor axis is going to be 2 times that. So 2 square root of 12, which is approximately 7 units. It's a little bit less than 7, but that's close enough. Okay, now let's find the foci. So remember, for the foci, we have the equation c equals the square root of a squared minus b squared. And that tells us c is the distance that the foci are from the vertices, or from the center, I'm sorry. So we're going to plug in and solve for c. So c equals the square root of 16 minus 12, that's our a squared minus b squared. So that equals the square root of 4, so c equals 2. So therefore our foci are going to be 2 units away from the center. So our foci, and since it's on the vertical axis, because this is a vertical axis major axis, we're going to add it and subtract it to our y coordinate. So we are going to have the points 4, and then -3 minus 2 is going to give us -5. And we have the point 4, comma, -3 plus 2, which is -1. So the last thing that we're going to figure out is the vertices on the major axis. And these are easy. We are just going to use our length of our major axes. So remember, our major axis is 4. But it's 8, but a equals 4, so we'll just add and subtract that to our y coordinate of our center to get our vertices. I kind of ran out of room here, so I'll go over it up here. So our vertices equal half of the length of the major axis that's going to be added and subtracted to your y coordinate since it's a vertical ellipse. So this will be 4, comma, and then -3 minus 4 is -7. And then we also have our other vertex will be 4, comma, -3 plus 4, so 4, comma, 1. Okay, so we have all the pieces of information. Now let's graph this. So our center is at 4, -3, so let's go for 1, 2, 3, 4, and down 3 units. So here is our center. We know that our foci are at 4, -5. So we're over 4, and we're going to go down 5. 1, 2, 3, 4, 5. So here's a focal point. and 4, -1. So here's another focal point. So these are our focal points, or our foci. We know our vertices are at 4, 1, and 4, -7. So there are all of our critical points on our major axis. And then we know where, we can figure out where our minor axes points will be, because we have it as a length of 7. So we know half of this, 3.5, is going to be to one direction. So if we have 4, we're going to go over about 3.5 units. So here is the other vertex of our minor axis, and over here 1, 2, 3.5 over here. So now we're going to draw our ellipse. Oh, that is messily drawn, but you kind of get the idea. That would be your ellipse, with our center right here and our 2 focal points, and then we have our major axis and our minor axis that has a length of 8 units and 7 units respectively. Okay, so let's move on to the next example. Okay, so now we're going to find the standard form of ellipse, and we're given the foci and the major axes. So since we have this information, we can come up with a standard equation. First thing that we need to do is we need to find the center. We're going to use the foci to get that center. So to find the center, we need to find the midpoints. So the midpoint of our x-coordinate is going to equal 4 plus 0 divided by 2, which is just 4 over 2, so that equals 2. Our y-coordinate, we don't even really have to do this one because it's just going to be 0 plus 0 over 2, which is just 0. Our y-coordinate didn't change. So that right there tells us that our major axis is going to be a horizontal line. But now we have our center. Our center is 2, 0. So we can already start to write our equation of our ellipse. We're going to have x minus 2 squared, and that'll be over the major axis, and then plus y minus 0, which is just y squared, and that's going to be over the minor axis, so we know this equals 1. Okay, so we need to find the a and b in terms of our major axis and minor axis. And remember, we have the equation c squared equals a squared minus b squared. And we know the major axis, and we can also find c. So we'll use that information to eventually solve for b. Since we know the major axis has a length of 8, we know that 8 equals 2 times a. So therefore a equals 4. So over here, we know that this is going to be 4 squared. We also can figure out our little c right here because we know the distance that the foci, the focal points, are from the center. And they're 2 units. So that means that c equals 2. So if we plug this information into our equation, we can now solve for b. So we're going to get 2 squared equals 4 squared minus b squared. So that gives us 4 equals 16 minus b squared. And when we solve this, we end up with b squared equals 16 minus 4, which equals 12. Okay, so since we know that b squared equals 12, that means b equals the square root of 12. So our answer here is going to be square root of 12 squared. And we're leaving it in standard form, which means that we're going to have our a and our b in terms of squared terms. But you could also write this as x minus 2 squared over 16 plus y squared over 12 equals 1. But we have now found the standard form of the equation of the ellipse using its foci and the major axis. Okay, we have one more example here. And first, before we go into that example, we're going to go over some applications of ellipses. So what are ellipses actually used for? They're used quite a bit. Actually, all of the planetary orbits are in the form of an ellipse. So the Earth orbits around the sun in the path of an ellipse. The moon orbits around Earth also in a path of an ellipse. Same thing with satellites. If we launch a satellite up in space, it's going to orbit around Earth in the path of an ellipse. Many architectural arches are also in ellipse. And also a lot of acoustical designs are going to be in ellipses where you're going to be placed at the foci to give the best acoustical sounding. So there's some applications. So now we're going to go into one last equation here, or problem, and we're going to use eccentricity. And remember, our eccentricity is the equation E equals C over A, where C squared equals A squared minus B squared. And eccentricity of an ellipse will always, always, always be between 0 and 1. And in fact, if our eccentricity equals 0, that means it's a circle. When eccentricity equals 0, this is telling us, remember, how oval of a shape the ellipse is. And the smaller that this number is, the closer that the focal points are to the center. Okay, so last problem here. Find the equation of the ellipse with vertices 0 and plus or minus 8. And we know that eccentricity equals 1/2. So the first thing that we need to do, find the center. So if we're given that the vertices are 0, plus or minus 8, we can tell from here that our center is going to be 0, 0, because this is going to go 8 units one direction and 8 units the other direction. The midpoint of this would be 0. You could also use the midpoint formula if you wanted to, but you don't have to. So our center is 0, 0. And we know that our major axis is going to be on a vertical axis because it's our y-coordinate that's changing. So let's go ahead and start up our equation. It's going to be x squared, because we have x minus 0 squared. That's going to be over our minor axes, plus y squared. That's going to be over our major axes, equals 1. Well, we can figure out the length of our major axes because we can find the distance of our major axes. If this is 0, plus or minus 8, that means that the two vertices are 0, negative 8, and 0, 8. So that means that this major axis has a length of 16 units. And that equals 2a. So a equals 8. So therefore we have y is going to be over 8 squared, or 64. You could have also written 64. Okay, so now that we know our major axes, we have our eccentricity, we can find our minor axes using this, because remember, our eccentricity is C over A. So we have the value 1/2 equals C over 8. And then solve this, we get C equals 4. 8 times 1 divided by 2. So now we're going to set up the equation like we did on the previous slide, and we've got 4 squared equals 8 squared minus b squared. So now we're going to get 16 equals 64 minus b squared. So therefore b squared equals 16 minus 64, which is 48. So b equals the square root of 48. So we're going to have over here the square root of 48 squared. And we've now found the equation. Okay, that's it today. I hope you enjoyed this and have a good one. Take care. Bye-bye.